Hello everyone, welcome to Computer Organization and Architecture class. In this unit, we will introduce Residue Arithmetic. A residual numeral system, RNS, is a numeral system representing integers using Chinese remainder theorem. For example, in 5794 residue numeral system, a decimal value 12 can be represented as 2530, which can be obtained by using the decimal value 12 divided by 5, and we can obtain the remainder is 2. Then again, 12 is divided by 7, and the remainder is 5. 12 divided by 9, and the remainder is 3. Last, 12 divided by 4, the remainder is 0. Thus, 12 in decimal can be represented as 2530 as the remainder from top to the bottom. Here is another example. Assume we have a decimal number 16 to represent it in 5794 residual numeral system. So we calculate 16 divided by 5, and we can obtain the remainder is 1. 16 divided by 7, the remainder is 2. 16 divided by 9, the remainder is 7. 16 divided by 4, the remainder is 0. Thus, 16 in decimal can be represented as 1270 in 5794 residue numeral system. As we mentioned in the adder design, the carry look-ahead adder attempts to overcome the bottleneck of addition-subtraction unit to obtain the carry-in for each full adder in advance. The residual arithmetic is another way to overcome the bottleneck. For example, as shown on the right, assume we want to add two decimal numbers, 29 and 27. In residual 5794 representation, 29 can be represented as 4121, and 27 can be represented as 2603. To get a sum of 29 and 27 in residual 5794, we simply add 4121 with 2603 so that we can obtain 6724. Then we perform 6 divided by 5. The remainder is 1. 7 divided by 7. The remainder is 0. 2 divided by 9. The remainder is 2. 4 divided by 4. The remainder is 0. Therefore, the sum of 4121 and 2603 is 1020, which is 56 in decimal. Another example demonstrates the multiplication in residual arithmetic. Assume we want to calculate the product of two decimal numbers, 10 and 17. In residue 5794, 10 can be represented as 0, 3, 1, 2, and 17 can be represented as 2, 3, 8, 1. To get a product of 10 and 17, in residual 5794, we simply multiply the corresponding digit of 0312 and 23A1 so that we have 09A2. 0 is coming from the multiplication of 0 and 2. 9 is the multiplication of 3 by 3. 8 is obtained from the multiplication of 1 by 8. And 2 is obtained from the 2 times 1. Then the first digit 0 is divided by 5, and we can get the remainder is 0. The second digit 9 divided by 7, the remainder is 2. The third digit 8 divided by 9, the remainder is 8. The last digit 2 divided by 4, the remainder is 2. Thus, the product of 0312 and 23A1 is 02A2, which is 170 in decimal. As you can see, we only need to deal with the corresponding digit when performing the calculation, and thus there is no bottleneck due to the carry-in. Please complete the extended reading to better understand how residual arithmetic works. Any question?